I'm sorry if there's like an alarm clock going off on my end because my roommate does not listen to his alarm clock and it might go off for about an hour. It's very annoying.
It's just relatable with me.
Does anyone want to go first?
I'll go first, as long as my group's not going to hate me immediately for it.
I'm down.
No, that's fine.
Let's do it.
Just get it out of the way.
Is everyone in your group here?
I heard.
Yeah.
I believe
Yes.
Dylan and Philip.
Well, then I guess you guys can go.
Okay.
Whenever you're ready.
All right, and I will share the screen. Wait. One moment. Sorry, trying to full screen it. There we go. Alrighty, and I believe Dylan was kicking us off.
Yep. All right. What's up, guys? This is our course project proposal on the creation of cryptocurrencies. And let's do it. Let's get right into it. So cryptocurrencies, it's exciting. It's a digital currency. And we believe it definitely has the potential to be like the next like global currency of like the future. It has it's decentralized, so there's no like central banks, there's no like Federal Reserve, you're not going to be able to print more Bitcoin. And with this decentralization, it's also this means it's like on a peer-to-peer network. So with this too comes more security, more freedom. There's a lot of like anonymity with it, which like is why it has like some criminal activity associated with it. But yeah, it's really cool. It's really new. And that's why also it's very volatile, as we've seen with like Dogecoin and Bitcoin and like the recent like crypto crashes. But yeah, that's about it for the introduction.
So for the current workflow, I'm David Munyon. And so first, we're going to be looking at the major players in the crypto world, right? Such as Bitcoin, Ethereum, Dogecoin. There's one called Shiba Inu out there. And we're going to be looking at like the technology that separates them from one another. And then we're going to also just look at the current blockchain technologies and how that has enabled just Bitcoins to be like cryptocurrencies to be created as they have in the past. And we're also going to look at other technologies such as like the distributed ledger technology, which has allowed the records keeping across like multiple decentralized networks and things like that have allowed for the cryptocurrencies to thrive like they have. Next.
So outcome, what we're hoping to get out of this, analyze the key technologies that enable them and make the differences and why one is better than the other, show the improvements from the different creation processes, especially considering this started in like 2007 as a paper outlined, and now it's 2015 and it's everywhere. And clearly the first attempt, not probably, there are issues, and there's innovations in the industry that, sorry, I'm blanking here a little bit. Basically, we're going to outline how these are created and what differences come out from the newer models that have been, created. We switched slides. That's what happened. Cryptocurrencies growing rapidly.
Hey, Connor, I can do the motivation slide real quick, and then we can go to conclusion.
Oh, did motivation get skipped?
Yeah.
That's what happened. I'm sorry. I did not intend to skip it.
It's all good. It's all good. So our motivation for doing this project is mainly just to gain a deeper understanding of how these cryptocurrencies work, because we hear about them all the time, and it's kind of like, like what is actually going on with this? like what technologies allow us to do this. So we're gonna focus on like the fundamentals, like blockchain, and the other thing is like a proof of work or a proof of stake, which basically allows the transaction to happen and allows it to happen like with all the anonymity and like security. We're gonna look at the implementations of how these currencies are like put out onto the market, and then we're gonna look at like some of the faults and improvements. So like the main thing with Bitcoin that would be like a fault is that environmentally it's pretty horrible for the environment because of the amount of electricity it takes to complete a transaction. But Ethereum, it's like a new crypto, and it's like working to improve on that. And so yeah, that would be the motivation.
Sorry, Dylan, I didn't realize. So cryptocurrency is growing rapidly. It's the big buzzword along with, blockchain, but very few people, in the layman's world knows how that works. Your parents might even know the word Bitcoin and maybe blockchain, but they have no clue how this works. But it's clearly making an economical impact, that they've risen to ridiculous levels of value, or commendable levels of value. But the research out there, explaining what the differences are, it's not explained. You look up differences and you see, why should invest in this and that, but it doesn't explain, hey, like you have to do a lot more digging to even see, Dylan's point of Bitcoin is a lot more environmentally unfriendly. So, and hopefully we can outline it simple enough that you might not be even able to create your own, as it's not impossible to, make a brand new cryptocurrency, but, documentation isn't as easy to follow as, hope. So, this is just our general timeline, what the rate that we're hoping to finish all of this is at. And then just a brief glance at our resources before we open the floor to questions and answers.
Yeah, is there any Bitcoin in particular you are looking to focus on, or just like a general overview?
Oh God.
So we're probably going to focus on like the big popular three, which is Bitcoin, Ethereum, and Dogecoin right now.
Okay.
I had a question about like the carbon intensity thing. Do you know like what part of Bitcoin specifically is like responsible for that, or why it?
So it's the Bitcoin mining that requires such like high power levels. I mean, some of these Bitcoin mining operations, I mean, they're like take the power of a small city almost. When you're just the mining operations, not the actual transaction. I mean, that's just like a very small amount compared to the mining.
Yeah, well, going off what Philip said, I read like something really interesting. It was like that Bitcoin like transaction could like power like a whole like house for like a day or something because of like, the electrical intensity.
Are you guys also going to look into, say, like smart contracts that like Ethereum has and maybe some others?
That has popped up in some of my research. Someone asked which ones we're going to focus on. Ethereum's the big one that especially the professor mentioned, that like this is the better example to build off of. And that's one of the key differences. But I haven't seen many things outline like mechanically how that works. So yes, we'll focus on that, but I don't have a good like clarification as of now.
All right, cool.
I did have one question.
Yeah.
So you said earlier in the presentation that Bitcoin enables more criminal activity. In what ways is Bitcoin enabling that criminal activity in regard, like as opposed to using, the US dollar or other fiat currency to do so?
Yeah, so I mean, with Bitcoin, like you remain anonymous. It's like very hard to track back to yourself, which is why like if you go on like the deep web and shit, like oh shit, sorry, oh fuck. If you go on like the deep web, there's like a lot of like black market stuff. because like you can't track it back to yourself.
There have been like large scale operations that have been found in the past, which is like Silk Road. When they busted the founder of that, I think they found like 250,000 bitcoins in his possession, like on his like various computers. And also, like we see the hacks recently of the oil pipeline, and the Bitcoin is enabling hackers to get paid without any like real like traceability almost.
Okay. I did have one more question too. Would your team cover the physical aspect of trading Bitcoin, like going into a store and buying something with Bitcoin? Is that something you guys would explore as well?
Maybe. We were trying to focus a little bit less on the economics at the professor's discretion. That still might fall under enough of the mechanics, but we're more about like both the creation of the new one and mining itself. And so that transaction's more, for lack of a better word, meat space instead of the actual digital world. And so like we'll obviously have to make some sort of nod towards the finances, and so that might get mentioned in there, but we're focusing on, you know, very much the technological as much as we can.
So I also have a question. I heard you guys were also talking about how much power this uses. I know, you know, we're doing very similar projects, and with Bitcoin, there is a, how do you say, a plateau or a top, the maximum amount of Bitcoins that can be produced per se. And I was wondering if you guys will also look into like how power usage over time, and you know, when, you know, it did say that there's a certain date when we may reach the max amount of cryptocurrencies. Are you guys going to look over that in terms of power usage maybe?
I'm gonna make a note of that. That's a very good point. I hadn't quite encountered that in our research, but that seems very much something we should focus on.
Yeah. So like in terms of like the max amount of Bitcoin, that I think that's more for like the economics. Like it'll prevent like inflationary like policies because you can't make more Bitcoin. Like there's was this one source that said like a single transaction. So like just like buying and like selling, and like in terms of like the Bitcoin, like the actual transaction itself like consumed the electricity. So like I don't see like how that would be reduced if it's a transaction, because there's always going to be like millions of transactions at a time.
Okay, that's fair. I'm just curious to see. Probably
if there's technology out there that like can like decrease that.
I was just about to ask about that.
Yeah, so like there's like this thing that Ethereum's doing called like proof of stake, which is supposed to like be more environmentally friendly. I gotta do more research into it, but yeah.
No, I know what you're talking about, but I was gonna ask a little bit about that, but yeah. Great presentation, by the way.
Thanks. I think I think we went well past the 2 minutes that he expected for Q&A, but you know, as expected, kind of.
Well, it hasn't been 15 minutes yet, but if no one has any other questions, then we can move on to the next presentation.
Okay.
Any takers?
Yeah, Lions and I will be going up next, if that's okay.
Yeah, go ahead.
All right, Tony has the
let me
screen share. Let me start my own recording as well before I start.
Is the presentation going through okay?
Yes, I can see it.
Yeah.
Cool. All right.
All right. Hello, everybody. Oh, wait, go back.
Yeah, you're good. My bad.
All right. Hello, everybody. My name is Lions, and this is Tony Du. Our team name is Bit Squad, and our course project proposal will be regarding the effectiveness of Bitcoin as a virtual currency. And we'll be mainly focusing on Bitcoin as the virtual currency of this research or literature review. So, what the heck is Bitcoin? What is Bitcoin? It's a digital currency released in 2009, and it's a completely decentralized type of currency. That means there are no central banks, there are no single administrators monitoring these Bitcoins. It's all peer-to-peer, user-to-user, node-to-node transactions, as explained in the previous presentation. These units are highly encrypted pieces of information. They're like in tokens, hex, hash codes, really, and they're exchanged across different users. And in a way that these things are stored like a wallet almost, it's stored in a digital wallet. These are controlled by the user, and that wallet does not have to remain in the internet. So yeah, that's pretty much what Bitcoin is, and a quick introduction to what Bitcoin may be to those who may or may not understand what it may be. Okay, so what is the significance of Bitcoin in our research? Well, with Bitcoin, as you may have all an interest in, it has a rising popularity over the years since its initial release in 2009. In 2009, it wasn't worth anything. It was worth probably like a tenth of a penny to a hundredth, and over time, it became prominent over time. People started using it because of anonymity, its quickness, and it's streamlined almost. And it took over daily news reports. You can see it local and national nowadays, and it's becoming a popular alternative to purchasing different products. You can see that it's available in even near on University Boulevard at UCF. You can find different ATMs existing for these cryptocurrency transactions, and you can use these types of things to purchase goods. I know that Tesla recently did use Bitcoin, had a Bitcoin option to purchase their vehicles with Bitcoin, but it did sort of, they did sort of just cancel that. But that's just an example of how Bitcoin can be used nowadays. Not only that, but we can also see activity reports such as financial statements of how Bitcoin is on the rise or on the fall, and how people can also be negatively affected by these Bitcoins, especially in scams and fraudulent activity. Now, with that being said, we're pretty much looking over, trying to see how the security works. How is it so advanced? How is it almost a brick wall to be able to hack through compared to other security systems like your own house security system? Why is it so difficult to hack these sorts of things? Why is it so difficult to open someone else's hard drive, someone else's wallet to get their Bitcoin? We know that it might be decentralized, but we were looking in ways to see that. And the only possible way to really hack into these types of things is just social hacking and being able to figure out their codes or passwords and usernames in order to access that, that sort of fragile information. But yeah, that's something to consider with the significance of Bitcoin. Moving forward, I will transition to Tony Du.
So essentially, with our project, we wanted to provide an overview for what Bitcoin is and basically look into how the Bitcoin network is set up, specifically focusing on like the blockchain part of it and how it's basically like a public ledger that shows the transactions of Bitcoin from like when it started to current day. We wanted to analyze this network and figure out like the strengths of it, any potential weaknesses, and effectively come to a conclusion on like how effective Bitcoin is as a virtual currency from a security standpoint. Like I said, we're going to be focusing on the public ledger and maybe seeing how it could possibly be a double-edged sword with how, since it's public, people can see the addresses for the Bitcoin wallets and see if that could possibly lead to a private security breach for the individuals. We want to look at how the decentralization of authority and like see how effective it is, where instead of having like a bank overseeing all the transactions, we would instead see how everyone keeps like an eye on each other and how effective that would be, as well as how the peer-to-peer transactions, cutting out the middleman, could also improve security by if one side has like a breach, then the other side isn't really affected because of the private like encryption code that they have. So overall, that's what our literature is going to cover, focusing on the security and reliability of Bitcoin as a global virtual currency. These are our references and open to questions from everyone.
Are you also going to look into the effect that mining pools have on the decentralization of Bitcoin?
Yeah, we know that like mining pools are definitely like a rising concern within like the Bitcoin as like, you know, because it's like the whole point of it is like if preventing like a majority of people from mining, and like that would cause a concern with like constantly getting access to the transactions and stuff like that. So that is definitely something we're going to look into.
Are you also going to since you said security, are you going to focus on like clipboard viruses and stuff like that? Where, you know, whenever you're entering, you're pasting a wallet address, they're going to change it to their own address.
That is also another aspect that we want to look at, like seeing how people could get scammed or like phishing and like other ways for like people to be attacked when using Bitcoin as a currency.
Any
Are you
more
going
questions?
to mention any of the like other cryptocurrencies, like just briefly to like compare, or are you just mostly going to be talking only about Bitcoin?
We're mainly going to be focusing on Bitcoin. Should it rise, that there may be other comparisons with different virtual currencies, we may bring it up, but it's most likely going to be covered Bitcoin as a general, since it's the most prominent form of currency compared to other currencies like Ethereum and Litecoin, all of that. So yeah.
Okay, I was going to ask about going off of that. If you were going to go off, like if you're going to look at other things other than Bitcoin, you know, maybe look at the speed difference between Bitcoin is lower than Ethereum or any of that. But since you're mainly focused on Bitcoin and the security aspect, I think that answers my question.
Yeah. Bitcoin really just, you know, influenced these other cryptocurrencies to come out. So that's why we wanted to touch on Bitcoin as a whole in general, because it covers it's where most cryptocurrencies started, and so yeah, that's pretty much why we're just gonna do Bitcoin for the most part.
How do you guys plan on divvying up the work between the both of you guys?
So I've known my man's Tony for a while now, and so we would make a great team, especially like ever since like freshman year. That's how I've known him, and so I know his work ethic. I know how well he works, and it's pretty much us just going with the flow as a duo, and you know, scheduling appropriate times to really do the research, really put in the work, really do the reviews, and I'm sure we shouldn't have any trouble, especially with the knowledge we have with Bitcoin. So yeah, it's pretty much just organization and flow, pretty much.
Yeah. Like I'm sure like at a future date where we'll like meet up and talk about it, basically assign like different topics to one another and then like set the date and time for when we would like come back with the information, discuss and like analyze the what we come up with.
Yeah.
Are you going to talk about Satoshi at all?
Satoshi, yes, the creator. We'll probably bring him up somewhere. You know, maybe if we could find some interviews regarding him. There's definitely a lot of stuff to look into here. This is just the proposal and the baseline, the front face of what you may or may not see. So yeah.
So a big portion of, oh, sorry, I'm not sure if I interrupted anyone. Big portion of your research is going to be looking into on the SHA-256, I'm assuming, and encryption, proof of work, and all that. Or is...
Yeah.
Yep.
I'm sure you found a lot of papers so far. Just by
yeah, we just like type in Bitcoin in the Google Scholar articles and you can find
everything popped up probably.
everything popped up. So yeah.
Will you cover like security and other aspects of the blockchain, or mainly just focus on like cryptocurrencies?
It'll just be the focus of Bitcoin. I mean, it exists within the same blockchain. If you go on a certain website, I think it's a blockchain.com, maybe you can publicly view the individual transactions organized into different hashes, with the time of when it occurred, and yeah, I think I'm not sure what else other information each transaction occurs, but it's just you can see each data strip, and we're pretty much just gonna cover what you have said with encryption, security, and how Bitcoin, is the most secure in terms of cybersecurity. So yeah.
If you said it's most secure, have you seen Monero?
No, I've never heard of that. We've never heard of Monero, but we can look into it. That's
Okay.
something to look into.
Let me write that down real quick.
Yep.
Okay.
And just give you like a whole new section to write about.
Yeah,
There
this
you
is why
go.
we like this. We like the question answers. It sparks and influences ideas. Is there any more questions from anybody else before we stop this recording for myself?
Just hand it off.
I think you did a great job. So.
Yeah, for sure.
Thank
Good
you,
job,
thank
dude.
you.
Thank you.
Appreciate it.
Who's next?
I think that is us.
Oh, okay, fun. Great.
Okay, you guys can see the PowerPoint and stuff and hear me, right?
Yeah, we can see.
Yeah.
Yeah, we
Okay.
can hear.
Okay, so our group is doing blockchain applications for autonomous vehicle networks, and that is me and Paul and the other Paul.
Yep.
So we're going to be looking into implementation of blockchain into the Internet of Things, and specifically autonomous vehicle networks in order to improve privacy and security of the networks, and then also just how the decentralization would be beneficial. So some problems that we think that blockchain would be able to solve as far as autonomous vehicles is just giving the ability to store very large amounts of data. There's lots of different data that needs to be stored, such as sensory information inside and outside the car. Some of the articles have even said that in addition to that, there'd be data based on like gas mileage and when it needs to stop to refuel and insurance and that sort of thing. So blockchain would be able to store that data. And then also that data doesn't only need to be stored, it needs to be protected because it's potentially sensitive. You don't want your car telling whoever has access to the internet, like where you're located and where you're going, how fast you're. Like there's some data that you do not want shared, so you want the privacy that is inherent to blockchain. And then in addition to that, not wanting other people to view your data, you really don't want people to be able to edit that data. Or like you don't want someone controlling your car. That'd be a very bad time. So the security inherent to blockchain would also help for that. And then another problem that I could potentially solve is the need for a centralized authority. So with blockchain, the data and like, I guess the power is sort of more distributed. So there would not be as much of a need for like one company or one person to be controlling everything.
Yeah, so the motivation with moving to the blockchain is as cars become more autonomous, they're going to be starting to become more and more connected. Not only just like cars that you would drive, it'd also be for like stuff in the supply chain, stuff like that. So like it comes to current problems in the supply chain is that you have all these different different agencies that in your supply chain, they hand off materials to one another, and then information kind of gets lost. And another thing is like talking to those different like services, maybe there might be like some errors, it's hard to track. And then maybe, you might be stuck in like a certain kind of like ecosystem. So that's like the trending towards centralization. And then we have like fragmented markets. So maybe Tesla has their own market. Everyone wants to create their own market and they can't really talk to each other. And then also the other thing is like as this machine, as like the cars are talking to each other, there's going to be like more and more like scrutiny on like the security of the communication between those cars. So another motivation is like why would you even want the cars talking to each other? Is maybe you can have like smarter intersections, or like you can have steps in your supply chain where materials are automatically offloaded to like other steps. And then you can also have maybe like autonomous like drone delivery services or taxis where like the drones will automatically know like my battery's getting low. I can just request a charging station on the decentralized network, and it'll automatically pay a fee to borrow that charging station in order to autonomously keep on working. So another thing is you can also have like autonomous taxis. You can maybe, like Tesla kind of has, their thing where they're talking about where you can put your car up to rent and then it can autonomously like drive people around. So you can imagine you can have stuff like that where like the financial transactions happen on the blockchain, but also you get more like transparency because like who's taking your car and stuff like that. And I also mentioned there's more, you have more like efficient intersections. So another thing is you can also store like your car certificates and other like location data on the blockchain more securely. So maybe you can like broadcast that data onto the blockchain for the cars within like a certain radius to pick up on. So you can also store like for insurance, you can also securely store like sensor data. And you can also maybe even do like vehicle lending temporarily, or you can more easily sell your car to someone else by just transferring like the NFT or something like that. So our objective is to provide like a brief background of the blockchain in order to like explain like why even use blockchain for these applications. And also we want to talk about like emerging consensus protocols and how like either mining or like staking would work with autonomous vehicles and stuff like that in the supply chain, or either like for like retail. So then we also want to compare like the blockchain based intelligent transportation systems, which is basically generally what this is, to centralized solutions, and talk about like the performance and trade-offs. So like just a little bit about the performance is like, like proof of work is pretty slow, at least when it comes to Ethereum, Bitcoin. But there's some other ones like Algorand's is providing, it has smart contracts. And at the current moment, it can do 1,000 transactions per second, which is about half of what Visa can do. But like later this year, they're hoping to do maybe about 45,000. Cardano is doing about 50, but they're hoping to do like up like about 1 million. But we'll see actually how that plays out. And then later, we actually want to describe the applications of using B-squared ITS and how like these different applications will actually benefit from using like a blockchain over some centralized solution. And then lastly, we want to talk about like current research and development to like maybe or even like real world current applications of using the blockchain for various aspects for like intelligent transportation systems, and also some like proposed ideas to what you can use it for.
All right. So looking at the current works, some of our initial research findings led us to papers that investigated IOV and how blockchain could be extended to vehicle networking to give a detailed theoretical analysis and numerical results. There's also a high efficiency delegated proof of stake consensus scheme that's been doing some research as a security solution to make a secure peer-to-peer data sharing system for IOV. Was also and IOV stands for Internet of Vehicles or something like that, and like IoT, but IOV. With the benefits, a lot of companies are emerging into the space. So you have like DABS protocol to allow anyone to use decentralized peer-to-peer transportation ecosystem that they have. Similar to, I'm building off of what Paul had said earlier about the drones. They have low battery, stuff like that. So, and then we have Ford coming to the space with the vehicle-to-vehicle communication. So they're trying to have applications in adaptive cruise control. And then we also have Volkswagen blockchain network aim to increase roadside safety by warning of nearby vehicles. All right, so here's our schedule. Preliminary major milestones that we have started looking at. So like the week 1 to 2, we kind of started already doing the technology investigation, looking at the papers, the research, current applications. Then we're gonna start working the paper. And obviously we have a short period of time to do all this before we present. So by week 5, we're hoping to have a good majority of the paper pretty much finished and then just start finalizing it so the next week we can present. The focus areas, I, Paul Maruso, am going to be doing the blockchain background. The other Paul is going to be working on B squared ITS versus centralized. And then Sierra is going to be working on the applications. All right, so kind of some concluding remarks. Blockchain is currently experiencing a rapid development with the potential to revolutionize intelligent transportation system and applications. The future of IOV data is expected to expand not only to roadside traffic data, but also to various sensory data from the vehicle, driving habit, human-computer interaction. There's also e-commerce with transaction data. So with car insurance, refueling transactions, things like that. Then we have selective privacy, where each user manages their own keys and each data block node only stores encrypted pieces of their user data. So there's no third-party access and control, with the exception of government's vehicle management office, something along those lines. And in looking at many of the applications of blockchain-based intelligent transportation system, which B squared ITS stands for, one of the most successful scenarios they're believing is going to be in real-time ride sharing, with companies like Uber already aiming to build an open source worldwide decentralized network. And we also see large companies like IBM that are taking this serious, as they are helping auto executives provide new services that are connected to consumer needs, and which you can see the quote right there, where they when IBM was interviewing with executives. And these are our references. We found a lot of information on research and on current works with like Ford, Volkswagen, IBM, and a lot of research into just implementation of blockchain. Any questions?
So you found works that this is already in motion to be implemented. Have you seen any I'm trying to phrase this better. When do you think this will actually see this hit market? Like, we'll actually be able to buy a car that does this type of interaction? Have you gotten any estimate on that?
It's still like early research, but I think more what it might be used for first is like in supply chains.
I think also something that might delay that a little bit is it's not like all of a sudden everyone's going to have these autonomous vehicles. So the first couple of vehicles are going to need to know how to interact with like normal cars. So that would kind of like delay these coming to market as well.
What type of verification are you guys seeing that a lot of them are using, like Ford and everyone else?
Sorry, what kind of verification?
Yeah, like proof of work, proof of stake.
Oh,
there's also a crypto called IOTA.
Like a delegated proof of stake.
Okay. Yeah. There's also like another one, I don't know if you guys want to research it or not, where in order to send a transaction, you have to verify 2 transactions.
Yeah, I'm not sure. I just know from a few papers there are different takes, like different proposed like consensus mechanisms specifically for like IOV, Internet of Vehicles. So, because it might be like
and are they small block time?
Are they what? I didn't hear you.
Are they like small block time so they can confirm quickly?
Yeah, small block times within like at least a few seconds, at most a few seconds. They're also talking about like where like different like main nodes, they could be like bistations on like intersections and stuff like that, where the cars could directly connect to or through 5G, stuff like that.
So it's kind of like a mesh network then?
Sort of, but all the transactions will be communicated through the blockchain. So either like the intersections could provide
Okay.
like the internet connection. So it's like I guess like a hybrid mesh in a way.
This is
Okay. So would it still work then if you, let's say, like lose cellular service?
Yeah, you probably would need like constant internet connection, but we'll need to look into it more.
Have you had difficulty finding research on this type of topic? Since
Specifically for like the internet of vehicles, it's been slightly harder. But in terms of like more like intelligent transport, that's hasn't been like too bad. Because the intelligent transport systems involves like everything from like keeping track of things in supply chain to actually like self-driving cars and stuff like that. So depending on like how much research we are able to find and write a paper, we may have to shift to more generalized like ITS.
Okay.
I did have one concern with the verification process as well, and I apologize if I didn't understand the concept clear enough, or if this question's out of the scope of your research. But say you have like an autonomous vehicle, and it's getting directions from a web service like Google Maps. The way I understand, let's say Bitcoin, for example, it takes about 10 minutes to verify transactions with Bitcoin. I would say that 10 minutes isn't.
Yeah, it would
really
not be
enough.
using any kind of like, most likely any kind of proof of work. It would be using mostly proof of stake and some like take on proof of stake where you can get block times of 50 seconds at most. So like Algorand can have a finalized block time of throughput of about 1,000 a second. So, and with different, their new protocol that's coming out later this year, they're hoping to get like over 10,000. So in terms of the throughput and block time, it's not gonna really be a problem. I mean, it's still going to be a consideration, but with the newer technologies, and you can utilize either like Algorand or some other like proof of stake, blockchain, and utilize their smart contracts to implement some of this.
All right, thank you.
Yeah, that was a great question, by the way. So
yeah,
thank you.
Any other questions? Okay, cool.
I like the presentation. I thought it was a unique topic.
Thank you. Yeah.
I guess we're the last group.
No,
All right,
one more before you. Let's see here. You guys can see the presentation window, right?
Yeah.
Okay, correct monitor, good. Let's go ahead and start this show. Okay, so I believe Bitcoin was a very good first try as a cryptocurrency and a very good definition of what cryptocurrency should be, but there are certainly ways that we can improve on Bitcoin. My topic of interest would be a literature review, exploring the ways Bitcoin was cutting edge and what technologies Bitcoin pioneered. And we'd also be exploring the pitfalls that came with using Bitcoin and ways we can improve future cryptocurrency. The motivation for this project was exploring Bitcoin specifically because it was sort of the first one and the one that got big. It's what everyone thinks of when they hear cryptocurrency, sort of the first in best dressed, if you've ever heard that idiom. Cryptocurrency, I believe, is a viable alternative to fiat currency, and it may even overtake fiat currency one day in the future. But what is fiat currency? Fiat currency is essentially money that is declared as currency by a government or by an entity such as banknotes or Federal Reserve notes in the case of the United States. It's not backed by any sort of physical commodity. For example, the US had the gold standard up until 1971, where in the gold standard we could have banknotes exchanged for gold at a fixed price. Then the US kind of switched to a fiat currency system because that gold standard system was sort of unmanageable. Regardless, you would need to place faith in the value of Federal Reserve notes for it to have any sort of value. There are a few problems with fiat currency. For one, it's susceptible to influence or action by the entity that manages it. For example, you could have a government declare more money minted and cause inflation, or you could have the government confiscate the currency and cause deflation. It's centralized. It's managed usually by one or a collection of entities, and it's minted by those entities. People are dependent on that entity to receive that currency. And with digital transactions specifically, third parties are needed to facilitate those transactions. I can't just go to Paul, for example. I can't just transfer him money. I have to do it through my bank. There's no built-in error checking. You have to place your faith in that institution that the money is going to get there and that everything is right. And you can be tracked and traced depending on the information that third party gets from you. So Bitcoin was pioneered in 2009 by Satoshi Nakamoto to solve some of those issues. If you may remember, around that time was when the Great Recession was happening, and it is speculated that that's one of the factors that led to the creation of Bitcoin. Bitcoin is essentially electronic currency, and its transactions are verified with cryptography. It uses hash functions alongside timestamps to ensure that transactions are valid and verified. I'd like to get a little bit more into hash functions in my review, but for those who aren't familiar with them, say you have like a pile of sand and a few cookie cutters. If you were to stack those cookie cutters in a sort of way and then drop the sand through one of them, it would come out in sort of a shape, and that's something you could repeat over and over again. If you dropped it in a certain way, it would always come out that shape. But it'd be very hard to reverse engineer the order of the cookie cutters if you were to just look at the shape that came out in the end to try and get the way the pile of sand was in the beginning. Bitcoin is independent of any sort of currency. It's not fixed or based against any sort of other currency. It's decentralized. It's not issued by any central bank or authority. You don't need to place trust in the validity of the currency because it just is. And there's minimal structure needed to support Bitcoin. It's peer-to-peer. There's no any sort of host or client or anything like that. It's just all clients. It incorporates proof of work transactions to where, transactions are verified with compute equations. Not necessarily, there's not any necessarily any risk that comes with proof of work besides time wasted, I suppose, as there is with proof of stake or other proof of whatever methods. And Bitcoin can be broken down into layers like we've been learning. You have the Bitcoin currency, You have the Bitcoin protocol and the blockchain, which are the app layer, the protocol layer, and the network layer, respectively. Your app layer defines the currency in the nodes. Your protocol layer just defines the transactions in the network. And your network layer defines the cryptography in the public ledger. Like I said, Bitcoin was created in 2009 near the financial recession or the Great Recession. So it's most likely that lack of faith in government and financial institutions sparked the creation of Bitcoin. It's also another motivation for it was freedom and anonymity when making transactions. Bitcoin has quite a few benefits associated with it, most of which sort of come with its structure. Essentially can be boiled down into two categories, decentralization and security. If you have something that's decentralized, you don't have to place your faith in any sort of institution or entity. It's in the people, of the people, and by the people. And it can be secure because it is transactions can't be deemed valid unless they are verified. You don't have to take anyone's word for it. You can find out yourself whether, Joe Bob and Billy Joe actually exchanged, Bitcoin for something. There are quite a few pitfalls with Bitcoin, which leads to its unsustainability. As it is, the blockchain is a few hundred gigabytes in size. It takes at least 10 minutes to verify a block of transactions, and you only get 7 transactions per second of max throughput. The only way to really decrease the verification time is to decrease the complexity of the cryptography or increase the efficiency of the cryptography. You could always decrease the block size as well, but that would just lead to a larger chain. And Bitcoin block size was set at a certain size to, what's the word for it? To kind of disincentivize spamming the blockchain. There's also time to start up a node. To download and verify hundreds of gigabytes takes days to do. And the cost per transaction is quite high with the electricity and the fees needed to confirm that transaction. So as of February 2018, the Bitcoin network consumed about 47 terawatt hours of electricity, which is enough to power a small country. Because of proof of work. The proof of work concept that Bitcoin pioneered is also sort of a double-edged sword. For small use, it's generally okay, but it requires a large amount of compute performance, a large amount of electricity, and then as more and more coins are mined, you get less and less of them, so there's less and less financial incentive, and that poses a security risk. If you don't have enough miners to keep the coin going, then there could be the coin could be taken advantage of. There's also 51% attacks, to where if you own 51% of the nodes in the network, then you could effectively create your own blockchain that would have to be taken as the record, as you have the majority consensus of the nodes on the network. And essentially you can falsify or counterfeit transactions. So one way we can improve on Bitcoin is to increase the block size. It's still on its original block size of 1 megabyte, It supports 4,000 transactions per megabyte. And like I said earlier, is intended to prevent the creation of large spam blocks. Another way you could do a better Bitcoin is to have sort of a lightning network aspect to it, to where if you have, if you're buying a few things on Amazon, right, and say you use Bitcoin to buy that, instead of doing one official transaction per purchase of an item, you could say purchase your items, and then all that is kept track of, and then at, say, like every month your net sum transaction is added to the blockchain, to where you would only have one big transaction per month instead of a few small transactions per month, decreasing blockchain size. We could have something called segregated witness. It separates the signatures of the users, of the clients, from the transactions themselves, and it would be able to increase the number of transactions while decreasing the cost of transactions. And proof of stake is also another thing that should be explored. It's used in Ethereum and Ethereum Classic. Essentially, proof of stake is the node owner stakes a large amount of coin on a block and generates that valid block for the network. And it's the network, even if, say, less and less people mine per se. Mine's not the right word for it because there's not really compute used, but the network is still secure even if you have less and less people mining the coin. And these are my references. Are there any questions?
I just had a quick one. You mentioned one of the advantages of Bitcoin was it was outside of like government control. Do you ever see that as being like sort of a problem though also? Because I know a lot of times when the government manipulates money, it's like to stabilize the economy.
I would say that's more of a philosophical question rather than a technological question. I suppose it's all just up to your interpretation of what government should be. Personally, I'm of the belief that the government is of, by, and for the people, and therefore control of the people's currency should be in the hands of the people, whether that may be a good thing or not. But like I said, that's more of a philosophical question.
Okay, thank you.
Yep.
How much are you going to be touching on? Oh, sorry.
No, you're good. Go ahead.
How much are you going to be touching on the reverse, like attempts of reverse engineering, like SHA-256 encryption, or if any?
Hashing is one of the things I would like to focus on, just because it's so key to the blockchain in general. So I don't quite know reversing attempts at hashing algorithms. I haven't quite explored that yet.
If anyone
but that is something I would like to explore. Yes.
Sorry. I know like there's like a reward of like a few $1,000,000 if you're able to reverse engineer SHA-256.
Yeah, that's why I brought it up.
Yeah, SHA-256 is pretty bomb-proof. So.
Yeah.
I only ask this because I feel like you had a lot of it in your presentation. Cryptocurrencies and things like Bitcoin, do you ever see them becoming like actually used currencies? Right now they feel more like investments and they're not exactly super stable. And I guess good currency would be something that's relatively stable for a long period of time.
I would say that I do see cryptocurrency in general as becoming a viable solution. I would say that volatility has to do with that's sort of relative to other currencies at the moment. I think that if a cryptocurrency were big enough, did become big enough and used enough to where you see it in day-to-day life, I think some of that volatility would go away, because I would see Bitcoin right now as more of an investment solution. Well, maybe it's not intended as an investment solution, but it's definitely being used as more of an investment rather than, actual currency that you go to the store and buy things with and that you order things with.
I also wonder about transaction times. If I go to the store to buy something, I'm probably not going to use Bitcoin because it takes 10 minutes for it to process, right?
Yeah, and that's one of the things that proof of stake and other, I know I saw some things like proof of space or other proof of whatever's. That's a pitfall that would be able to be solved by proof of stake, and that's something I would like to cover more. As in the last group's presentation with their Internet of Vehicles, they touched on, proof of stake being able to have greatly reduced block times just because compute performance wouldn't need to be weighted on for a transaction to be verified. But good question.
All right. Thank you.
Mm-hmm.
All right, if no one else has any questions, we can move on to the next one. Maybe the last one, I'm not sure.
Yeah, I think that's us.
Yep. All right. Here we go. All right, can you guys see it?
Yeah. Mm-hmm.
Cool. Guess we'll go ahead.
All right, so we're going to be presenting on the storage of data in blockchain used for currency transactions, and the group is me, Jacob, and Benjamin.
So blockchain is a technology that has the possibility to present solutions to a lot of different problems. Some of these are banking, cybersecurity, supply chain management, a lot of different things. We're going to be focusing mainly on the cryptocurrency stuff, which I guess is not new in this group of people, but yep, that's what we're going to be doing.
Okay, so the problem with blockchain is that it's a new disruptive core technology, but we're going to show basically how it's going to be transparent, tamper-proof, and it's going to be open to everybody. So right now with any transactions, there's also the trust and the transparency with corporations. So you're entrusting, a bank like Wells Fargo or a credit card company like Visa to pay the merchant and then take the money out of your account and honor the transaction. So there's always going to be a central authority that controls information that they're only going to reveal what they want you to see. So they're never going to tell you the exact amount of transactions that they can do. They're never going to show you, who sent who money. It's never going to be, like the Venmo tab where you can see your friend sent other people money. It's all just going to be untraceable except for them. So there's a large incentive to lie whenever money is not traceable as well, because if you don't know that people sent money, they don't have to pay taxes on it. You can send money back and forth and you can hide it all in person, kind of like getting paid under the table if you're doing jobs. So you have to hope that they want to voluntarily show you the information, but they're not always going to do that. Sending money to other countries is also super expensive because you have to wire it back and forth. You have to, a central authority and hope that, the money will actually get to where it is. And then if it doesn't, or they give you the wrong address, they're going to take a huge fee of that money, 20, 30% just for their efforts. Finally, inflation is going to be controlled by the government rather than a finite currency. This way, right now they've been printing a bunch of money during the pandemic instead of letting it adjust by itself. That's a good and a bad thing, but again, this should be the people's currency where the market will react to the supply and so forth.
All right, so we're going to cover 3 different main topics in this paper. So the first one will be the wallet, which is how we will send and receive cryptocurrencies. The second method would be mining cryptocurrencies and creating them, and the verification of those cryptocurrencies. And the third topic will be the actual data stored within a transaction of these cryptocurrencies.
We will also look into some technology improvements. We already heard about proof of stake, proof of work, and proof of authority, and they all relate to the creation of transactions. So we will look into some advantages and disadvantages that come with each of them. Another improvement we'll look into is a larger block sizes that allow fees to become cheaper and fit more transactions.
So another point of this is, since we're focusing on the inner part of the transactions, like the data, in it, there's a bunch of currencies that can take advantage of this data, and VeChain is one of them. They track basically the authenticity of purchases, and they have for supply chain. So you can actually look at their currency in their blockchain and authenticate, let's say, a Louis Vuitton handbag, that it was the farm the leather came from, where it was processed, and that's all stored in the blockchain up until they made the purse or something. And that's where the block sizes come in, because we can cram more data into each transaction, making it more secure. So our preliminary literature review is going to be based on the three things: the wallet, the miners, and the data inside. So we're going to be focusing on the sending and receiving of transactions, and then adding the data to the transaction that'll get processed by the miners. So this is where we're going to input the data that's going to be permanent inside the blockchain. So for example, in a car, when you want to add an oil change, instead of needing to rely on another company to do that, it'll all get added into a blockchain that anybody can look at. Therefore, it's the public information. The miners, those are going to be the verification computers that basically authenticate the data we're putting into the blockchain and then confirming it forever. This way it can never be changed again. And then our data, once it's confirmed, it's unchangeable, it can never be modified, and it's open source for anybody to view based on a block explorer. Other data, a transaction can store a currency, messages, as well as other cryptocurrencies. So that's going to be the ERC20 tokens, where you can actually layer another currency on top of a base foundation, such as Ethereum. And you can have multiple coins that are quickly deployable on top.
All right, our schedule is pretty general. Week 1, we're going to be gathering our materials. Week 2 and 3, we will start writing the paper and research as we write it. Week 4, we will create our presentation and finalize the paper. Finally, week 5, we present the paper and submit it. I will focus on cryptocurrency mining and verification. Benjamin will focus on the data stored in transaction, and Leslie will focus on cryptocurrency wallet.
Just to conclude, our goal is to do the literature review, where we summarize and understand the main characteristics of the blockchain network regarding the efficiency, the security and storage and transactions, and consensus mechanisms. And we're just gonna talk a little bit about, like we said, the wallet and how each transaction works.
References. And any questions?
Could you explain proof of authority more if you know?
Yeah, so proof of authority is kind of centralized right now. It's not necessarily great for huge blockchains until it gets more developed, but it's basically, you're going to be delegating a few moderators or admins that are going to start confirming the transactions and then become trusted sources of verification. And from there, it can be spread out, and they can delegate other authoritative figures that can also verify transactions. So it's kind of, a spider web of trusted people, but it has to get built out before it can truly work well.
Okay.
So you guys going to be looking at like the current technology, or are you guys going to be looking at like future implementations that can make it more efficient?
It's going to be kind of both. So we're going to pull current technology and then look at its pitfalls, if there are any, and then how to properly expand them and overcome the challenge that they are.
Do you know how proof of authority differs from delegated proof of stake?
Not in a great sense, no, unfortunately, but we can look that up. All right, is that it?
Seems like it.
Cool.
Be a great presentation.
Yeah, good job, everyone.
Yeah.
Sir, yes, sir.
So just double checking, Paul's gonna upload the recording and then we're gonna timestamp that in our submission.
Yeah, I think
Yeah,
we'll upload it.
Right. Can we go back to the main room now to confirm that we finished?
I
I
think,
think we do.
yeah, I think
What? He's been tagging people who are completed.
Oh, he has. Okay. I'll stop recording.